So our next topic is about limits. So we know that we can redefine calculus as a branch of mathematics that enhances algebra, trigonometry, and geometry through the limit process. Or calculus simply will not exist without limits because every aspect of it is in the form of a limit in one sense or another. So to illustrate this notion, consider a second line. So we know that we have here a second line. So we know that a second line is it is it is a line in which it is connected. It has 2 points. So it has 2 points. So here is the first point, and then the second one is the second point. So a tangent line, it has only 1 point that are attached with the curve. So assuming in this kind of curve, the tangent or slope of a curve as a limit of the slope of a second. So um, in this figure, uh, consider a second line whose slope changing until it will become a tangent line. So or a tangent or a slope of the curve at point P. So before so here is our second line. So at a certain time, as the time or it depends on the value of such x, so it became a tangent line. So this is uh this is an illustration to the statement that we had tackled about, that limits is so important in the calculus. So here is the so also another is by considering the area of a region bounded by curve shown in figure A and then B and then C. So the area can be approximated by summing up the areas of series of rectangles. As the number of rectangles increases, the sum of their areas will be close enough to the area in C. We can then say that the area of the region bounded by a curve is a limit of the sum of the areas of the approximating angles. Okay, so this area, I think this is applicable in the integral calculus areas. So just take note this kind of we have there applying areas. So now, therefore, we can therefore state, or we could said that or define the limit is limit as a number or as a number such that the value of a given function remains arbitrary close to this number when the independent variable is sufficiently close to a specified point. So that was our our definition for the limit. Now let's go to the theorems of limits. So if f of x is equal to c, a constant, wherein c is a constant, then limits and our limits for the function of x equals to c, wherein x approaches to a. Also, if limits k of x is equals to k, so limits f of x wherein x approaches to a, k is being constant. The third one, so in terms of a sum or difference of two functions, so the limits of f of x, positive, negative, g of x, wherein x approaches to a, this will become equal to the limits of f of x, wherein x approaches to a, positive, negative, or plus minus limits of g of x, wherein x approaches to a. So therefore we could say that the limits that we had here, this is not literally equal to the given function, but this is approximately equal, or the value is approaches uh, to the exact value. So in the fourth one, so the limits f of x times g of x, wherein x approaches to a is equals to the limits of f of x wherein x approaches to a times the limits of g of x wherein x approaches to a.
Device is now disconnected.
The fifth theorem is when the limits of f of x divided by g of x wherein x approaches to a is will be equal to the limits of f of x wherein x approaches to a divided by the limits of g of x wherein x approaches to a, provided that the limits of g of x is not must not be equal to 0. So the sixth theorem is when the limits of the root or the nth root of the f of x is equal wherein x approaches to a is equals to the nth root of the limits of f of x wherein x approaches to a, provided that the limits of x approaches to a f of x is a real number. So the seventh one is the limits of sine x over x wherein x approaches to 0, this will be equal to 1. X must be in radians. So here is our first example. So if we are going to evaluate the limits of x squared plus 3x minus 5 wherein x approaches to 4. So what we need to do is just substitute the value of x in the given function. So our given function here is x squared plus 3x minus 5. So what we need to do is just substitute the value of x, which is equal to 4, in the given function. So overall, uh, x squared will become 4 squared. 3x will become 3 times 4. So the x is substituted with the value of 4 minus 5. So overall, we could say that the limits of x squared plus 3x minus 5, wherein x approaches to 4, that our value is equals to positive 23. Next one. So we are going to evaluate the limit of function y raised to 3 plus 5y minus 1, wherein y approaches to negative 2. So at this point, the same method in the previous problem or example problem, the value of our y, just what we need to do is just substitute in the given function, wherein our function is y raised to 3 plus 5y minus 1. So y raised to 3 will be substituted with the y will be equal to negative, or will be substituted with negative 2 raised to 3 plus 5y negative 2 minus 5 minus 1. So overall, our answer is negative 19. So in our third example problem, so we are going again to evaluate the limit of uh, 2t squared plus 1 divided by t raised to 3 plus 3t minus 4, where t approaches to 0. So again, what we need to do is just substitute the value of t approaches to 0, or we will replace t with 0, because in the statement at t, it approaches to 0. Again, approaches means it is not equal, it is not equivalent, or it is not equal, it is just approximate, or the approximate what do you call this, almost equal with the value. So limits, so our t will be substituted with 0, so 2 0 squared plus 1 over 0 raised to 3 plus 3 times 0 minus 4. So overall, our answer is equal to negative 1/4. Now let's try some examples involving zeros and infinity. So how about if we have such functions wherein our t or any variable it approaches to infinity or zeros. So now let's try some kind of samples. So uh, let us going to evaluate the limits of 1 over s e raised to negative st wherein t approaches to infinity. So there is an infinity that is involved here. So again, if we are going to recall, we know that an infinity, this is a big number, right? We cannot say, the only thing that we can say is that infinity is an unknown number, but it is a big number. So 1, 2, 3, 4, and so on. So first step that we are going to know is we are going to just simplify first the function. So 1 over s. So e raised to negative st, we know that this is also equal to a 1 over e raised to s times t. So now let's going to substitute now the t approaches to infinity. So let's going to substitute all the value of t substituted with infinity. So 1 over s, so 1 over e raised to s times infinity. Now we know that any value or so s times infinity, we know that this is also this is equal to an infinity because any value of s, so infinity is infinite is already a big number. So if you're going to multiply any number, so therefore we could say that is also an equivalent of an infinite number. So s times infinity is an infinite number. So 1 over e raised to infinite number or infinity. So at this point, we know that the e, this is equal to, this is a Euler number which is equals to 2.718, right? So if any value, so a 1 over e raised to 1 divided by a big number. So for example 1 divided by, so for example 1 over e raised to 1, so this is equals to 1 to 1 over 2.72, or this is equals to 1 divided by 2.718 is, so this is 0.36368. So how, so what, so if 1 over e raised to 5, so the answer would be 1 over e raised to 5, the answer is 0.00067. So as you observe, if as the number or as the value of our infinity, as it goes higher, the the um the value is decreasing. So at this point, if our e or the value of our infinity is assuming that it is the value is 5, assuming, so 0.006. So how about if the value of our infinity is much bigger to our assumed the assumed 1 and 5? So it means that 1 over e raised to infinity, this is equal, or we could say in practical thinking, that 1 divided by a big number, this is automatically or approximately equal to 0. So we can say that 1 over e raised to infinity is equal to 0. So 1 over s. So therefore our answer for this kind of example is 0. So the limits of 1 over s e raised to negative st, wherein t approaches to infinity, is equal or approximately equal to 0. Next, the next one is we are going to evaluate the limits of 1 over s e raised to negative s. So the same function, but our t approaches to 0 here in here. So the same method kanina, what we did is we simplify the equation, and then after that is we now substitute the value of 0 wherein the value of t wherein t approaches to 0. So 1 over e raised to s times 0, and we know that s times 0 is 0, so that is e raised to 0. So we know that any value or any function raised to 0 or any variable, so e raised to 0, this is equals to 1, or 5 raised to 0, this is equals to 1, or a raised to 0, this is equals to 1. So therefore we could say that this is equals to 1 over 1, or a raised to 0 is equals to 1. So this is equals to 1, and then overall our answer would be 1 over s. Therefore, the limits of 1 over s e raised to negative s times t, wherein t approaches to 0, is equals to 1 over s. Next, let's try some trigonometric functions in terms of limits. So, how about if we are going to evaluate the limits of b cosine bt divided by e raised to st, wherein our t here is infinite, or it is an infinite number. So the same technique, what we need to do is we need to, so this is already simplified one, so we need to substitute the value of t wherein it is approaching, it approaches to infinite number or infinity. So b cosine b times our t will be substituted with infinity, then e raised to s times infinity. So again, we know that any number that could be multiplied by infinity, we know that an infinite number or infinity is a huge number, so we could say that s times infinity is equals to infinity. So b cosine, so again b times infinity is also infinity. Okay, so so the same. So now cosine theta is this is cosine theta, this is so let's try cosine of 1. Cosine of 1 is, this is already equal to 0.999. How about if we have cosine of 5? So we are going to try to assume the value of infinite number. So the cosine, the value for the cosine of 5 is 0.9961. So how about if we try cosine of let's say 45 degrees. So cosine of 45 is equal to, this is 0.7, 0.71. So we could say that we we are going to assume that the cosine of the the cosine of an infinite number, we could say that in this in our illustration, that as the value of the, or the assumed value for our infinite number is, it decreases or it is increasing, so as the value of the infinite or the assumed here is it is big, so this, it is equivalent to zeros na siya. So we could say that cosine of infinite number is, this is 0. So 0 times b is 0, and then e raised to infinity. So again, so let's try e raised to infinite. So how did okay, so any, so okay, that's okay. So 0 divided by e raised to infinity, this is automatic equal to, to 0. Kasi any number divided by or our numerator is 0, this is automatic 0. So that's, so therefore our limits for b cosine b of t divided by e raised to s times t, where t approaches to infinity, our answer is 0. Now, in our example number 7, we are going to evaluate the same function, but the only difference is that our t approaches to 0. So the same method, we need to substitute the value of t to 0. So b cosine b of 0 divided by es raised to 0. So we know that cosine we know that b times 0 is 0. So we have a b cosine of 0 divided by e raised to 0. So we know that cosine 0, this is equals to 1. So So this is equal to 1, so therefore we could say that this is b times 1, or and then also e raised to 0 is also equal to 1. So therefore we could say that b divided by 1. So our answer is b. So therefore the limits of b cosine bt divided by e raised to st, wherein t approaches to 0, is equals to negative, no, positive b. Next one. So how about if we have this kind of example that we are going to find the limits of b sine bt divided by e raised to st, wherein t approaches to 0. So next step is to substitute, wherein t approaches to 0, b sine b of 0 divided by e s raised to s times 0. So b times 0 is 0, s times 0 is 0. So b sine 0, no, sine 0, we know that in the, if we are going to find the value of sine of 0, this is automatic equal to 0. So therefore, we could say that b sine of 0 divided by e raised to 0. So sine of 0 is 0. So 0 times b is 0. So e raised to 0 is 1. So therefore, our answer for this kind of limits, so wherein our limits, so the limits of b sine bt over e raised to st, wherein t approaches to 0, is equals to 0.